Let's dive into natural language processing. NLP is a rapidly evolving field within artificial intelligence that aims to bridge the gap between human language and machines. It equips computers with the ability to understand, interpret, and generate human language in its various forms, spoken, written, or even signed. This opens a world of possibilities for applications that can revolutionize communication and interaction between humans and machines. And this is a quote generated by natural language processing from Gemini. Let's look at each of these titles to learn more about NLP, starting with applications or tasks. Natural language processing finds applications in a vast array of domains, and here we have another quote from Gemini for you. The applications of natural language processing include tasks for natural language generation and natural language understanding. These tasks include retrieving, processing, and extracting information from unstructured text. Some tasks include transformation type tasks, where we're transforming text to speech or speech to text, machine translation, translating text from one language to another, and text summarization. There is also classification tasks, such as sentiment analysis, spam detection, named entity recognition, and grouping texts by topics such as intent, urgency, bias, the actual topic, etc. There is also generative chatbots and virtual assistants. And of course, the quotes that we're seeing from Gemini on this site. Gemini is a generative chatbot. And these tasks include conversational, question answering, text and code generation, and text and code completion. From Hugging Face, which is a resource for natural language processing, this is a screenshot of the models available, which shows a lot of the tasks in natural language processing. So we said that natural language processing includes natural language generation and natural language understanding. Again, we have a quote from Gemini. NLU deals with complexities of human language understanding, which requires robust models, and NLG, while still challenging, benefits from some controlled settings and clearer objectives. Natural language understanding is generally considered harder than natural language generation. So why is that so? Here's some topics that explain why NLU is harder than NLG. NLU deals with understanding the meaning and intent behind language. So this involves some complex tasks like disambiguating words when words have multiple meanings, recognizing sarcasm or sentiment, inferring unspoken context, and handling grammar errors and incomplete sentences. NLG focuses on generating human-like text based on a given meaning or data, and this is a more controlled task where the core information is already defined. NLG can leverage techniques like selecting the appropriate vocabulary and grammar to use, structuring sentences coherently based on that vocabulary and grammar, and tailoring the language style for different target audiences. Data challenges between the two. For NLU, natural language is inherently ambiguous and it's constantly evolving. So training these NLU models requires a lot of diverse and high-quality labeled data to account for the various scenarios and nuances. And this data can be expensive and time-consuming to collect and annotate. I briefly mentioned Hugging Face, and in Hugging Face you will find models that are already pre-trained using massive amounts of data, so it's a good place to start if you don't have the data available to you. because that is one of the biggest challenges in natural language. NLG systems often have access to structured data or clear instructions on what to generate. So while the quality of the text depends on the training data, it's generally less sensitive to data variations than natural language understanding is. There are also evaluation challenges. In NLU, evaluating models is subjective and complex. There's no single perfect metric, and performance can vary depending on the task at hand and the data set that's being used. In natural language generation, models are easier as it often involves metrics like fluency, grammatical correctness, and how well the generated text aligns with the desired meaning or style. So NLG, in that sense, is easier to evaluate the models than NLU. And of course, there's real-world complexity. The real world is messy, so NLU systems need to handle unexpected situations, noise in the data, and adapt to a constantly changing language usage. Whereas NLG systems typically operate in a more controlled environment with well-defined inputs. While factors like audience and style do need consideration, NLG often deals with less unpredictable situations as compared to NLU. To get more specifically into these challenges, a primary challenge with natural language understanding is dealing with this ambiguity. So that is, a word, phrase, or sentence can have multiple meanings. And ambiguity arises in many forms and requires disambiguation techniques to handle that. So what are the different kinds of ambiguity that we have to deal with in natural language processing and certainly natural language understanding? There is lexical ambiguity, and so these would be words with more than one meaning. For example, words that have the same spelling but different meanings. Bat can be a baseball bat, or it can be a flying mammal. Bank, can, present, or present has different meanings, right, but the same spelling. So obviously that's a lexical ambiguity that is challenging to deal with. There's also words, when we're dealing with speech to text, for example, words that have the same sound. So they may be spelled differently, but they sound the same. So for example, buy, there's 3 variations I put here of buy, or 3 variations of that. And of course, there's many other words that have the same situation. And then there's proper nouns. So some proper nouns that are also common nouns. So for example, the name Jack can be a person's name, or we might be referring to a tool, a jack. Mark is another example, and of course there are many names and proper nouns, so not just names of people, but names of places and things that are ambiguous. There's also semantic scope ambiguity. So this is sentences with more than one meaning. So for example, if we look at this sentence, I can see the man with glasses. So there's ambiguity in what the subject is here. Am I the subject, or is the man the subject? Am I saying here that I can see the man when I have my glasses on, or am I saying that I see a man and the man is wearing glasses? There's also plurality ambiguity in semantic scope. For example, they only ate the pizza. That could mean that there were multiple options of things to eat and they only ate the pizza, or it could mean that multiple different groups of people only ate pizza. And then preposition ambiguity. There's a dog with a frog on a log. Is the dog with the frog and they're both on the log, or is the dog with a frog that's on a log? So you can see the ambiguity in sentences and their semantic scopes. There's also contextual ambiguity, for example, sarcasm, hyperbole, metaphors, implied meanings, and cultural nuances and dialects. So these all contribute to contextual ambiguities. And then, of course, there's evolving language ambiguity. Language is continually changing. Slang, for example, changes across generations. Internet slang, which is something that came with the World Wide Web. And these are, shorthand notations that arose with the internet. And then there's also emoticons and emojis that we find in text. And of course, technology growth is also contributing to this evolving language. When cell phones came out, we had new words like mobile and text. And text, of course, these were both already words, but now they have new meanings. Email came with the words and new meanings for spam, and a new word, phishing. Smartphones came up with more new words, selfies, smishing. And as we continue adding new technologies, we're going to continue evolving new words in our language and adding to our vocabulary. And then there's also ambiguity with errors, misspellings and typos. So determining if a word is misspelled and what its actual spelling should have been. There are people who write and choose the wrong words. For example, the word there is a word that is often misused. And then poor grammar in general. When you're reading text, if the text is not grammatically correct, then that is going to be harder to understand. So some of the things that we do in natural language processing, specifically text processing, which is the foundation of natural language processing. So you're cleaning and prepping the text to be used in your natural language models. The processing steps included in NLP pipelines include sentence segmentation, so splitting a text into sentences, followed by word tokenization, so splitting those sentences further into words, text normalization, which includes stemming and lemmatization. So stemming is stripping suffixes. For example, saying gets stemmed to say, which is the stem word. And then lemming is reducing to the root word. So for example, said reduces to the root word say. There's also stop word analysis, identifying and pruning those stop words from the text. For example, a, an, the, so common stop words. Dependency parsing, which is deriving grammatical structure and word relationships. Part of speech tagging, so labeling words with the part of speech. For example, is it a noun or a verb? And named entity recognition, so recognizing those proper nouns, locating and classifying named entities. This image here is coming from spaCy, which is a technology that we use in NLP, and this is just an image of spaCy's NLP pipelines that include the steps that we see here. And the overall level of analysis that we look at can be categorized into these 6 different levels. Lexical, which is your vocabulary, so words. Morphological, the different forms of the words, and many texts that you read will combine lexical and morphological as a single level, but here I have them split out into 2 separate levels. There's the syntactic level, which is looking at grammatical structure. The semantic level, that is looking at the meaning of sentences or phrases. Pragmatic, which looks at context and intent. And finally, discourse, which looks at the coherence of connected sentences. If you click on Learn More here, you will see some detailed descriptions of language analysis and these 6 levels described at different levels of granularity. So you can use this as a resource when learning about the different levels. And finally, we want to quickly look at some of the technologies that we use in natural language processing. So of course there are many, and they are adding every day. So every day we're getting new technologies that are coming out. So I've only listed here some of the more popular, widely used technologies across natural language processing. Python is, of course, the programming language of choice. And the Python programming language has a lot of libraries that are used in natural language processing. Data processing and manipulation tools include Pandas, which is a Python library for data manipulation, and NumPy, which provides some fundamental numerical capabilities for Python. And there are machine learning frameworks and libraries. So another comprehensive Python library for machine learning algorithms is scikit-learn. And for training models, we use TensorFlow and PyTorch, and these are both open source frameworks for building models. And finally, Keras, which is a high-level neural network API, which is designed to run in front of PyTorch or TensorFlow that sits on top of those lower-level libraries that allow developers to build faster without getting bogged down with the complex details that are in TensorFlow and PyTorch. And then there's some, these technologies that I've looked at here are not just for natural language processing. They're also used in machine learning and deep learning, in AI in general. But some specific NLP frameworks and libraries include NLTK, which is a Python library that gives us a lot of support for doing things like classification, tokenization, stemming, tagging, parsing, semantic reasoning. A lot of that text pre-processing that we talked about in the processing pipeline steps can be handled in NLTK. There is also Spacey, which is a free open source library for NLP, which features a lot of the techniques that we talked about as well. And if you'll recall, when we looked at text processing, this image that I took is from Spacey's NLP pipelines, and you can go to the link here and see how to perform these tasks in Spacey. And going back to our technologies, finally, there's Hugging Face. So I mentioned this a couple times. So Hugging Face is a hub for open source natural language processing tools, models, and data sets. So this allows developers and researchers to share, explore, and collaborate on the latest advancements in NLP, which is vastly accelerating innovation in the field. So some of the models that are out, for example, ChatGPT, early versions of that you can find on Hugging Face that have been open sourced that you can use for your own research projects. Other tools that we may sometimes use include cloud platforms and tools. For example, AWS has SageMaker, which is a managed platform for building, training, and deploying machine learning models. Of course, you can deploy machine learning models on AWS without using SageMaker. In fact, that's what I do. But SageMaker makes it easier for some folks. Google Cloud also has an AI platform with a suite of tools, and Microsoft Azure has a machine learning platform. So these are our top three cloud providers and the platforms that they have made available for natural language processing, but also AI in general. There are model deployment and monitoring tools, so for deploying your models after you've trained them. Docker is used to package applications with their dependencies so that they can be easier deployed. Kubernetes is an open source system for managing containerized applications across clusters. And MLflow helps manage the machine learning lifecycle. And finally, there's collaborative tools that some researchers do use. And I know a lot of students use these when they're learning natural language processing or deep learning or machine learning because it enables them to work in a cloud environment where they don't have to spend a lot of time setting up their own environment. Jupyter Notebooks are popularly used. Google Colab is a free Jupyter Notebook environment in the cloud. And then TensorBoard, which is a visualization toolkit for TensorFlow. that enables you to visualize your training data and model architectures. So some of these tools can be used online to collaborate and do your research and for learning. But the main tools that you'll want to familiarize yourself with for natural language processing is certainly all the tools listed here. So learning how to write code in Python, learning the pandas and NumPy libraries. If you learn pandas, really, it's kind of uses NumPy under the hood. So I don't think you need to spend a lot of time digging into NumPy itself, but you should be familiar with it. But you'll get a lot of exposure to NumPy just using pandas. And of course, scikit-learn for any machine learning algorithms that you want to run. Classification, clustering, we'll be talking a lot about those techniques, and scikit-learn is a good library for accessing different tools to do those tasks for you. And then learning either TensorFlow or PyTorch. They're both quite popular. TensorFlow is used more in production, whereas PyTorch is often used more in research spaces. So definitely learn one or become familiar with both. And Keras is optional if you want to use Keras with either TensorFlow or PyTorch. Keras can sometimes abstract away some of the details of these frameworks. And of course, in natural language processing, you should absolutely become familiar with NLTK, spaCy, and of course, Hugging Face. I will make a link to this website available to you, and you'll have this for your review. And this is a large collection of many topics across natural language processing. And of course, we will be going into many of them in a lot more detail as the course continues. I hope you enjoy your week and enjoy doing your assignment this week. I did give you 2 options for your assignment this week. One of them is a writing assignment and one is a programming assignment. So if your goal is to go into natural language processing in terms of software engineering, then I highly recommend you do the programming assignment. But some of you are in business degrees, so you might be more interested in just learning about the technology in general, and in that case, you might just want to do the writing assignment. So you have those 2 options available to you. Choose whichever one you want. You only need to do one, and then submit that. All right, thank you. Enjoy your week.